Now let us solve the example given here. If a person weighs 750 Newton on Earth, how much would be his weight on the moon, given that moon's mass is 1 upon 81 of that of the Earth and its radius is 1 upon 3.7 of that of the Earth. Now let us write what is the information given here. So given information, weight of the person on Earth is given here. It is 750 Newton. Now ratio is given here. Ratio of mass of the moon upon mass of the Earth. It is equal to 1 upon 81. Ratio of radius of moon upon radius of Earth. It is 1 upon 3.7. Now let us solve. W is equal to, W means weight, WE means weight of the person on moon. It is equal to mg. It is equal to g me and small m upon re square. Now therefore weight of the person on Earth is 750 Newton. It is equal to gravitational constant g into mass of the Earth, let us take as it is, into mass of the person upon radius of the Earth, its square. Now therefore m is equal to 750 into square of re means radius of the Earth upon g into mass of the Earth. Now let us find weight of the person on moon. Now weight of the person on moon, it is equal to, it is against mg. G into m means mass of the moon into m means mass of the person upon rm square. Now put the value of m here. So value of m, it is equal to 750 into re square upon g into me means mass of the Earth into g into mass of the moon upon radius of the moon, its square. It is equal to, now g means gravitational constant is cancelled with gravitational constant, and it is equal to 750 into mass of the moon upon mass of the Earth into radius of the Earth upon radius of the moon, its square. Now put the value of these ratios. Weight of the person on moon, it is equal to 750 into, now ratio of mass of the moon to the mass of the Earth is 1 upon 81 into ratio of the radius of the Earth upon radius of the moon. It is reciprocal of the ratio radius of moon upon radius of the Earth. Therefore it is equal to 3.7 and its square. It is equal to 750 into 1 upon 81 and into 13.69. Now do the calculation. So after calculation it is 126.76 Newton. So final answer, the weight of the person, weight of that person on moon, it is equal to 126.76 Newton. Now compare the value of weight of the person on earth and weight of the person on moon. Weight of the person on earth upon weight of the person on moon, it is equal to 750 Newton upon 126.76. So after calculation, what is the result? It is exactly 5.9. It is exactly 5.9. This way, the weight on the moon is 1 upon 6th that of the weight on the earth. Now let us learn about waves, various types of waves. We know that waves are created on the surface of water when we drop a stone into it. The waves generated on a string when its end are held in hand and it is shaken. Also, a light is a type of electromagnetic waves. Now various types of electromagnetic waves are there. Depending upon wavelength, which is minimum to maximum. Here wavelength is minimum and here wavelength is maximum. So depending upon the wavelengths, the electromagnetic radiations are divided in various types of waves. With maximum wavelength, it is radio waves. Then microwaves, then infrared waves, then visible light waves, then ultraviolet rays, then X-rays and gamma rays. These are the various types of electromagnetic waves. We know that astronomical objects like sun, earth, moon, various types of object which is astronomical objects that emits the waves, and we receive that waves using a different types of instruments. So it is very interesting thing. It is a learning thing. All our knowledge about the universe has been obtained through these waves. Astronomical objects emits various types of waves. You are looking infrared waves, then visible waves, visible with our naked eyes, then X-rays are there. So different types of waves emitted by astronomical objects. We can receive that waves using various types of instruments. And by using these instruments, we got the knowledge about the waves, not only waves, but that astronomical objects also. Now let us learn gravitational waves. Gravitational waves are a very different types of waves. They have also called as fabric of space and time. If we draw a graph in the space with respect to time, then its shape is like a fabric. Therefore, these waves are called as fabrics of space-time. Albert Einstein, which is very firstly predicted their existence in 1916. These waves are very weak waves. It is very difficult to detect that gravitational waves. So scientists have constructed extremely sensitive instrument and observatory that is called as LIGO, Laser Interferometric Gravitational Wave Observatory, which is situated at United States. Exactly after 100 years of the prediction by great scientist Albert Einstein, scientists detect the waves coming from an astronomical sources. Indian scientists have also contributed significantly in that discovery. This discovery has opened a new path to obtain the information about universe. Let us do an activity. Take a small stone in your hand. Which forces are acting on that stone? Now release the stone. What do you observe? What are the forces acting on that stone after you release it? So this is activity for you. When you hold a stone in your hand, which force is acting on the stone? Yes, two types of forces are acting on it. One is the gravitational force, which is directed towards center of the earth and vertically downwards. Another force, that is force applied by you, also acts on that stone. Therefore, stone is remains as it is. It do not falls from your hand. But when you release the stone, what is your observation? So when you release that stone, a force applied by you is become zero, and only the vertically downwards force, that is gravitational force, acts on that object, and therefore objects falls down. What are the forces acting on the stone after you release it? Yes, only the gravitational force, which is acts on the stone vertically downward direction. Force of gravity due to the earth acts on each and every object which is present on the earth's surface. When we are holding a stone in your hand, the stone was experiencing this force, but it was balanced by that force which is applying by you on the stone. As a result, stones remains rest. Once you released the stone from your hand, the only force that act on it is gravitational force, and that's why the stones fall downwards. When only gravitational force is acts on the object, then objects falls vertically downwards, and that is called as free fall. Let us learn about free fall. Whenever an object moves under the influence of only gravitational force, then it is said that the body is falling freely, or body is in free fall. For example, when we release stone, it is in free fall. Okay. Next example, the moon and the artificial satellites are revolving, are moving only under the influence of gravitational field. of the earth. Thus they are in free fall. The initial velocity of object is 0. Now let us see. When we drop that stone, the initial velocity of that object is 0. But it is goes on increasing when gravitational force acts on that object vertically downwards. The frictional force due to air opposes that motion. When you drop that object vertically downwards, we release that object or stone vertically downwards, two types of force which are acts on that stone and it is opposing the gravitational force. First is the frictional force of the stone and the air. So frictional force is acting opposite to the gravitational force. Also another force is there which is called as buoyant force. This force is also opposes the gravitational force applied on that objects. So these two types of forces are acting on the falling stone. So actually we cannot say that this stone is in a free fall, because these two types of forces are acting there. If no any other force rather than gravitational force is acting on the body, then it is called as the body is in free fall. So free fall is only possible, look at that sentence, free fall is only possible in vacuum only, because in vacuum no force like frictional force or no force like buoyant force is acting on that object. Only the gravitational force acts on that object. Therefore free fall is possible only in vacuum. Now this is the definition of buoyant force. The buoyant force is actually directed towards upward direction. So upward force is exerted on an object when submerged in the fluid. When any object is submerged in the fluid, then that fluid tries to push the given object in upward direction. That force is called as buoyant force. For a freely falling object, the velocity on reaching Earth and time taken for it can be calculated by using Newton's equation of motion. You know the three equations given by Newton. One, first equation, that is V is equal to U plus AT, where V is final velocity, U is initial velocity, A is acceleration and T is time taken. Second equation, S is equal to ut plus 1 half at square. Third equation, v square is equal to u square plus twice as. So these are the three equations of motion given by Newton. Now for free fall, when object in a free fall, that is only gravitational force is acting on it, the initial velocity is 0. Therefore u is equal to 0. And the acceleration is equal to acceleration due to gravity, means a is equal to g. Now put that u and g in above three equations. What will the equation becomes? First equation becomes, when you put u is equal to 0 and a is equal to g, then v is equal to gt. Now second equation, s is equal to ut plus 1 half at square. Put the value of u is equal to 0, then 0 into t, that is 0, and put the value of a as g, then the equation becomes s is equal to 1 half gt square. Now third equation, that is v square is equal to u square plus twice as. Again here u is equal to 0 and put a is equal to g. That's why v square is equal to 2gs. So when a body is in a free fall, the three equations of motion becomes as V is equal to gt, S is equal to 1 half gt square, and V square is equal to twice gs. Let us learn significance of the value of g. Means when we take the value of g as positive and when we take value of g as negative, let us learn that significance. This significance is depends upon the direction of g. When object is thrown upward directions, so object is thrown in upward direction, then value of g is negative. Now when object is thrown downward, it is in the direction of the acceleration due to gravity, therefore the value of g is taken as positive. So when you put or when we throw the object in upward direction, then value of g is negative. When you throw that object in downward direction, then value of g is positive. Direction opposite to the velocity. So if it is direction of velocity and gravitational force acts on the opposite direction to the velocity, then value of g is negative there. So in the direction of velocity, if direction of velocity is like this and direction of gravitational acceleration is also in the direction of velocity, then value of g is taken as positive. So remember this significance of the value of g. Now the value of g is same for all objects at given place on earth. So what is the meaning of this sentence? Let us learn. And we are at this point. So value of g means gravitation acceleration due to gravity is same for all objects which are present here. So for all the objects present here, the type of gravitational acceleration due to gravity is same. Thus any two object, irrespective of their masses and any other properties, when dropped from the same height, falling freely with will reach the earth at same time. When two objects are here, they may be with the different masses m1 and m2. These two objects are at the same height from the earth's surface. So any two objects, irrespective of their masses and any other properties, when we drop these two objects on the surface of the earth from same height, and when they falls freely, falling free means what? When only gravitational force is acted, gravitational acceleration is acted on that object only, and not any other force like frictional force or buoyant force, then body is said to be in free fall. And so that free falling objects reach the earth at same time. So both of these objects reach that earth at same time. This is scientist Galileo, which performs and states that any two objects with different masses, when thrown vertically downwards, that two objects reaches the earth's surface, the ground, at same time. Galileo is said to have performed an experiment around 1590s in the Italian city of Pisa. In that experiment, he dropped two spheres of different masses from the leaning tower of Pisa to demonstrate that both the spheres reached the ground at the same time. From that tower, Galileo throws two spheres which are of different masses, M1 and M2, M1 and M2. That is Tower of Pisa, to demonstrate that both the spheres reached the ground at same time. Then he shows that both these spheres with the different masses reached the Earth's surface at same time. When we drop a feather and a heavy stone at the same time from a height, they do not reach the earth at same time. Why this happens? But Galileo states that when any two objects with different masses are thrown vertically downwards, they reach the ground at the same time. But it is not in the case of feather and heavy stone. Why? Because the feather experiences here a buoyant force and a frictional force due to the air. Therefore, it floats in the air and reaches the ground very slowly, later than the heavy stone. The buoyant force and frictional force acting on stone is much less than the weight of the stone. Therefore, it does not affect the speed of the stone. Recently, scientists have performed this experiment in the vacuum and showed that feather and stone also reached Earth's surface at the same time. Let us watch this video.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest. Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, we have to remove the air.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCV 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Exactly.
Look at that.
They came down exactly the same. Wow.
Look.
Watch right there. Look at how they hit right there.
Exactly.
You're back on the side.
Exactly the same.
Feathers don't move, nothing.
Look at that. That's just brilliant. Isaac Newton would say that the ball and the feather fall because there's a force pulling them down, gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this. The reason the bowling ball and the feather fall together is because they're not falling. They're standing still there is no force acting on them at all. He reasoned that if you couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the Earth. So he concluded they weren't.